All right, so we got the rational roots theorem homework. Boy, it's got a lot of stuff in it too. This is a big assignment. Took us 2 days to do. So we'll start off with number 2, the rational zeros. I know you guys are used to things being A, B, and C, but this is the mind your P's and Q's. And we call the first coefficient we see a P, we call the second one a Q. And there's an old saying, it's mind your P's and Q's. Now, I'm not certain, but the math teacher in me thinks that it comes from this. So to create our list of potential rational zeros, we find the factors. And I've got this backwards, actually. Let me call that one Q, that one P. We find the factors of P. And we put them over the factors of Q. All right. So the factors of P here are going to be, and we're thinking about what it takes to make a 24. In an organized list, it's going to take a positive 1 or a negative 1. It's going to take a positive or negative 24 because those two make 24. I know I need a 2. If I'm divisible by 2, I'm 12. I need a 3 and an 8. And I ran out of room, didn't I? Shouldn't try to show that from left to right. I need a 1, a 2 enters 24, a 3 enters 24, a 4 enters 24, a 6 enters 24, a 12 enters 24, and of course 24 enters itself. Now Q is 3, plus or minus 1, plus or minus 3. Your full list here happens when you do the division. So the full list is going to be the 1, the 2, I'm dividing by the 1, the 3, the 4, the 6, the 12, the 24, and then we can divide by 3, the 1/3, the 2/3, the 1, which happens again, 4/3, 6 over 3 is 2, it's already been talked about, 12 over 3 is 4, it's already been talked about, 24 over 3 is 8, which I left off, plus or minus 8. Need a plus or minus 8 in here somewhere. There's a full list of the factors, of potential zeros. So awesome. I've got a list of zeros, and now what do? Well, now I do something called guess and I check, and I guess and I check, and I guess and I check. So if a number is a 0, the way I teach this is the result of synthetic division has a remainder equal to 0. So I'm going to do a lot of synthetic division. Of course, I already know the answers to this one because I created the problem, but I would tend to stay away from these big numbers. I would focus more on the smaller numbers. So let's just start with 1. So I put a 1. This problem requires placeholders. 3, there's no x cubed, a negative 6 at x squared. There are no x's, and then there's a negative 24. And I dropped the 3. 1 times 3 is 3. 0 plus 3 is 3. 1 times 3 is 3. Negative 6 plus 3 is negative 3. 1 times negative 3 is negative 3. 0 plus a negative 3 is negative 3. And 1 times negative 3 is negative 3, which is negative 27. Not a 0. All right? Why? Because it has a remainder. So I start over. Maybe 1 didn't work. Oh, I remember doing this in high school too. Oh, I remember. It stunk. And if you actually try to do this, you'll remember it. And you'll remember it forever because it kind of stinks. All of the guessing and the checking really, really stinks. So 1 didn't work. I'll try a negative 1. And I drop, and I multiply, and I add, and I multiply, and I add, and I multiply, and I add, and I multiply, and I add. And so this didn't work either. All right. Well, since I am the creator of the problem, I may as well quit wasting your time. Let's hope I remember these answers. Let's try a 2. So we drop the 3, we multiply and get a 6, we add and get 6, we multiply and get 12, we add and get 6, we multiply and get 12, we add and get 12, we multiply and get 24. And there's a 0. Now, because I got a 0, the next time I do synthetic division, I can reuse these numbers. 3, 6, 6, 12. Now, the other answer to this one happens to be negative 2. Negative 2 times 3 is negative 6. Sum is 0. Product of negative 2 and 0 is 0. They add to 6. Negative 2 times 12 is negative 12. We get a 0. Do remember this is the remainder, the constant, the x, and the x squared. So what has happened is I have pulled out 2 zeros, and 3x squared plus 6 remains. There are 2 more zeros here according to the fundamental theorem of algebra, so I set are equal to 0. I subtract my 6. I divide by 3, and I counteract squaring by square rooting. Don't forget your plus or minus symbol. Now, recall that I is the square root of negative 1. So if I see plus or minus root negative 2, I know that it is an imaginary root of 2. So I've got 4 zeros. They were plus or minus 2 and plus or minus the imaginary root of 2. And you are asked to factor over the complex number system. So if positive 2 is a 0, x minus 2 is a factor. If negative 2 is a 0, x plus 2 is a factor. If I root 2 is a 0, x minus I root 2 is a factor. And if negative I root 2 is a 0, x plus I root 2 is a factor. Now do remember that the very first thing you see in any polynomial is the letter A. And that was this 3 up here. That's still going to be there. Has to be there. Fun stuff, huh? I love it. Polynomial with rational coefficients has the given roots. List 2 more roots of each equation. So I'll do number 4. So here we have an imaginary number. We have a complex number. And it's in the form a plus bi. Now the conjugate of a plus bi is a minus bi. When you're forming conjugates, you always change the sign on the weird part. And I say weird, but that's how it is. Change the sign on the weird number, all right? And what's weird here is the 5 minus 5i. 5 minus 15i. So 2 more roots are going to be 5 plus 15i. That's one of them. Then I have this guy here, the 17 plus square root of 3. And the root of 23 is the weird piece, okay? I hope you agree that, if you look at 17 plus the root of 23, you should agree that root 23 is the weird piece. So all I have to do is change the sign on the weird number. So if 5 plus 15i is a root, then 17 minus square root of 23 is the other one. And what's going to be funny here is, please do not actually write squirt 23. Like, you're going to do it too, because God bless you. You just copy and you don't know much. You probably don't even have audio on to hear me say square root. But don't actually write that. Use your square root symbol. Like this guy right here. Don't write squirt 23. But you're going to. Bless you. All right. What are the real and complex roots of the following functions? What is the polynomial in factored form? So this one ought to be some fun, huh? Which one would I like to do? I think I'm probably going to do number 6. I think that's the one I want to do. Now, it's a 6-degree polynomial, so you're going to have 6 answers to this thing. And nobody's saying it's going to be a whole lot of fun. I don't think it will be. Normally, you try to reduce to a quadratic, but I don't know if we're going to be able to do that on this one or not. But let's see. All right, so here's my Q. Here's my P. We're going to mind our P's and Q's. We make our little list about P over Q. We'd have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12. And then what, plus or minus 18, and then plus or minus 36. And I'll be sitting pretty over the understood 1. So this is my list of potential rational zeros. So I'm going to pull 2 of these out. I'm going to just start with this guy, because why not? It's small. I am going to need some placeholders, like there's 1x to the 6th, but I sure don't see an x to the 5th. There's 4x to the 4th, but I don't see x cubed. And there's a minus 41, but I don't see an x. And then there's a plus 36. Anyways, I'm going to start with the 1s here. I'm going to drop, I'm going to multiply, and I'm going to add. I'm going to multiply, and I'm going to add. I'm going to multiply, and I'm going to add. I'm going to multiply, and I'm going to add, and negative 41 plus 5 is negative 36. And then I'm going to add, multiply, and then I'm going to add, and then I'm going to multiply, and there's my 0. Now, since 1 worked, I'm going to turn around and try negative 1. So I got a 1, multiply, and they add to that. They multiply, and I add. I multiply, and I add. I multiply, and I add. I multiply, and I add. And this is what I'm left with. So we have a remainder, a constant, an x squared, an x cubed, and an x to the 4th. Sorry about my voice, it's disappearing. I have x to the 4th plus 5x to the 2nd minus 36. There's 4 zeros here. Now, normally I would reduce to a quadratic. That is the usual goal. The goal is to reduce to a quadratic. That is the normal goal. But I noticed when I saw the numbers that I have a 4th degree polynomial that factors. So I stopped. This is special. Just like all of y'all. This one is special. It factors. It takes an x squared and an x squared to create x to the 4th. Factors of 36 are 9 and 4. Positive 9 minus 4. I guess I could have went ahead and plugged in 2 and 2, couldn't I? I probably should have done that. But anyways, I noticed this one was special. So I went ahead and just stopped. And now I'm going to use my zero product property. You know, x squared minus 4 is 0, or you can factor x plus 2 times x minus 2. It's up to you. X squared is 4, x is plus or minus 2. So there's 2 more zeros. We have x squared plus 9, we set equal to 0. That does not factor. There is no sum of 2 squares formula. X squared is negative 9. and x would be plus or minus the root of a negative 9, which shall be imaginary. This is plus or minus, I don't know why I'm writing I, 3i. I was about to write I3. All right, complete factorization's up next. We found these zeros here, 1 and negative 1. If 1's a 0, x minus 1 is a factor. If negative 1 is a 0, x plus 1 is a factor. If 2 is a 0, x minus 2 is a factor. If negative 2 is a 0, x plus 2 is a factor. If 3i is a 0, x minus 3i is a factor. And if negative 3i is a 0, x plus 3i is a factor. And the A is that understood one, which I don't need to write. Good times. All right, write the polynomial of least degree that has rational coefficients. A leading coefficient is indicated in the given zeros, and you begin by setting up factored form. You don't forget about conjugate pair theorem, and you may leave it in factored form. So these guys are kind of weird, right? If 4 plus 2i is a 0, 4 minus 2i is another 0. If 1 plus root 7 is a 0, 1 minus root 7 is another. All right, let's go ahead and write this thing out. I want you to remember that all your factors are x minus something, right? They're x minus a number. That's what they are. And things change sign when they enter parentheses. Okie dokie. So we have 3 as a factor. We have 3 as a 0, x minus 3 as a factor. By the way, a is 4. That needs to go out front. When you look at this one, these bother kids. This is x minus all of 4 plus 2i. Think about the distributive property. Signs change, but I've been telling you that forever. Signs change. Both pieces are going to become negative. X minus 4 minus twice I. All right, we'll go ahead and do this one next. Both pieces change signs. X minus 4 plus twice I. Now I'm looking at 1 plus root 7. Both pieces change sign. And now I'm looking at 1 minus root 7. Both pieces change sign. Ta-da! Moving forward. I don't want to do that one. Farmer will use 400 foot of fencing to enclose a rectangular plot that borders a river. He will not fence the piece next to the river. Draw the scenario. This is a typical math problem, but if you don't put a fence in the river, your cattle are still going to escape. I guess maybe this is an out west problem, where fences are built to keep animals out, not in. Let's see here. The ultimate goal here is to create an area function. An area is length times width. This rectangle has a length and 2 widths. So when we talk about this rectangle in the context of this problem, the perimeter is 2 widths plus a length. Now I have 400 foot of fencing, so 400 is 2 widths plus a length. Talks about writing this as a function of x. Since L is the single one, we're going to make that L, okay? 400 minus, W. 400 minus twice W is my length. So I'm going to write it as a function of width, actually. And I'm able to take this, and I'm able to throw her right there. So area as a function of W is going to be 400 plus twice W times W. Now, I'll put it in standard form in a minute, but this is where we check domain, okay? I know that the width has to be bigger than 0. That's true. And I know that the length also has to be bigger than 0. And the length is 400 plus twice W. So it also has to be bigger than 0. That's just how this works. Anyways, this is going to give me a funny answer. 2w greater than negative 400. W is greater than negative 100. This is gibberish, right? That's gibberish. Okay, so the other thing here that's actually a big deal, that one was gibberish. It wasn't what I answered, what I wanted here. The perimeter maxes out at 400. And I'm missing something here. You know, the question is, where is it going to stop, right? So the width is bigger than 0. The length has to be bigger than 0. Actually, they can be the same. That's the only thing that I think really matters in the context of this problem. I mean, W had to be bigger than negative 100, but that doesn't make any sense. When you take the widths and the lengths and put them together, you can't exceed 400. So there's something there. But it's kind of hard to do a domain there. So anyways, just ignore me. That's the only thing that I can make sense by looking at it algebraically. This guy needs to be in standard form, so you distribute your W. Area as a function of width is 2w squared plus 400w. All right, part C, find the maximum area possible for the farmer to enclose. Right there, this happens at opposite b over 2a. So the width that maximizes this is the width coordinate of the vertex is opposite b over twice a. It's a formula we've used countless times. B is 400. Negative 400 over twice a, twice a 2. It's negative 400. This is negative. That's what's throwing me off. Crap. Oh. So, that's why I'm so confused here, isn't it? Glad I caught that. Wish I would have caught it sooner. So back to my domain problem. This is what was throwing me off. The width has to be more than 0, and this factor here, 400 minus twice the width, has to be more than 0. Jump over, negative 2 widths greater than 0, greater than negative 400. Divide out the negativity, and W has to be less than 200. I got that guy, I got that guy. I end up with something that looks like this as an interval. That is your domain. Anything from 0 to 200 is the width. Now that I have rectified my issue, and forgive me for making a mistake, I do the distributive property. I get negative 2w squared plus 400w. And now I'm going to find the w coordinate of the vertex. It's going to be opposite b over twice a, just as before. So negative 400 over twice a 2, twice a negative 2. And that'll give me 100. So since I have the width, I can get the length, right? Right there, or I don't know, maybe right there. So the length is 400 minus twice the width. It's going to be 400 minus 200, which is 200. So the max area possible is going to be 100 times 200. You know, you can go old school on this if you want. 1 times 2 is 2, and there's 1, 2, 3, 4 zeros. 2,000 square foot. There you go. Think. Or is it 20,000? Pretty tired this morning. I'm having a bad teacher day, apparently. I'm going to check that, because I just don't feel right about that. I feel like it's going to be 20,000, isn't it? Yeah, missed a 0. Bad math teacher today. I should probably quit while I'm ahead. 20,000 cubic foot. Factoring practice. I don't know if I want to do any of these or not, because you're the ones who need to practice with factoring. All your forms are up top. And these do need to be factored completely, as far as you can, anyways. 16 is kind of a cool pattern. If I remember it right, you've got an x squared squared minus a 9 squared. And that's going to factor as x squared minus 9 times x squared plus 9. But wait, there's more, because this is a x that's squared and a 3 that's squared. So it factors as x minus 3 times x plus 3. That one's kind of cool. I just don't want to do a lot of these. Like, you kids really need to be doing some of these things. 14 seems like it was kind of cool. It takes a 3x squared and a 3x squared to make 9x to the fourth. Factors of 1 are going to be negative 1 and positive 1. And that doesn't work now, does it? Because that will not create 8. So I guessed and I checked. I don't know why I wasted time like that. Apparently I'm off. So if I need a positive 8, I need to add 9, and I need to take away 1. So this is the piece that turns around and factors again, because it takes a 3x and a 3x, and a plus and minus 1 to add up to the understood 0x that's in the middle, and you have x squared plus 1, which does not factor with real numbers. It factors over the complex system, but not with real numbers. If you want to factor it, it's x plus or minus I. And the last one I'm going to do, and that's where I need to stop. Write the transformation rule that turns f of x into g of x, and you're supposed to use something called Bach. This is the order of transformations, okay? So something has happened, and this thing went this direction, and that's b, because b is, sorry, that's not b, that's h. H is the horizontal shift. B, which is the first thing you're supposed to do, is the horizontal compression. Let's just start over on this. So, sadly, students need lots more instruction on this stuff than I really care to give, because I don't want to remember it. B is the horizontal stretch or compression. H is the horizontal shift. A is the vertical stretch, compression, and it also handles reflection. If it's negative, something happened, and you have K, and K is going to be your vertical shift. Okay? So I went to the right, and I also went down. Yeah, I have to follow this order. So there wasn't a horizontal stretch. That didn't happen. But I went right. I went right 1, 2, 3, 4, 5, 6, 7, 8, 9 units. And I have stretched it. Notice how it changed from having initial slope of 1 to initial slope of 2. A is 2, but it's also downhill, so negative. And there's also a vertical shift. I went down 1, 2, 3, 4, 5. I lost 5. Now what you're plugging in here, you're plugging into this transformation form. G of x is going to be AFs of x, B times x minus h plus k. And I don't think the state of Tennessee is going to ask you about B. I don't intend on giving you anything that deals with B, because I just don't think they're going to mess with it. So A was negative 2. A was actually 2, but the fact that it's negative means we have a reflection. I went right 9, so x plus 9, and then I shifted down 5. There's your transformation. That'll do the job. Go right 9, fall 5, and you're done. So anyways, That didn't go as well as I wanted to this morning. I was not on my game, and I apologize.